minute. This is my new app, FHIR Assistant. Is an assistant using AI to get summary of patients and generate charts and get information about patients using natural language. I will present to you the architectural features of this app. In the last videos, I presented this application, and in the previous video, I show you the source code, and in this video, I will detail to you the architectural features for this app. Here we go. I prepared to you an architecture and markdown file with all architectural details for this app. So the high-level architecture, and you can use this architectural layout to create other applications using AI and the InterSystems IRIS. And now we have here the user, and we use it stringlit UI because stringlit allows to you write Python, and this Python code will render as screens, as user interface like this. So this is stringlit screen UI, a modern UI to run your features, okay, using Python only. So the stringlit UI call AI layer using Ollama and the Llama 3 LLM model running in a Ollama server, a local server, and this AI layer you use embedded Python running inside InterSystems IRIS, communicating with a FHIR server. FHIR Server is a feature of InterSystems IRIS. FHIR Server is a repository into InterSystems IRIS database to store clinical data using FHIR standard, okay, and this InterSystems IRIS FHIR data can be handled as vectors. I can using Ollama and Llama 3 to generate the tokens, AI tokens, and store into the IRIS vector DB. Okay, so with this feature embedded Python using Ollama and Llama 3, I can generate embeddings from the clinical data stored in FHIR, and these embeddings are stored in the Systems IRIS and can be used to do vector search and smart search in using VectorDB. Okay, so as you can see, InterSystems IRIS is a core of the solution, because within InterSystems IRIS we have a FHIR server, a FHIR API layer, you have embedded Python running and the business rules of the app. We have a vector DB to store the embeddings of AI, embedding the FHIR data in vector DB to Ollama use this embedded data to respond to send responses to the user using this information. So before InterSystems IRIS, this app is not possible. Okay, is the core of the solution. So when you can see, Iris is very important to this architecture because these FHIR capabilities. Iris provides a fully compliant FHIR R4 data and APIs. You can use Iris interoperability features also to connect with external data from from any companies, external or internal apps, and centralize this clinical data inside a FHIR repository. And Iris provide to you native ingestion of data using BookFire resource. You can use the data loader to load external data to inside Iris using raw JSON. I used this feature to load an initial data set to use in the application. Okay. Other feature very interesting in Iris is the multimodal data platform. Iris handle JSON FHIR data as relational data. You store the FHIR JSON, but you can query the data using SQL language. Okay, or you can use vector search if you want. Okay, and the vector search in the InterSystems IRIS allows to you save data as vectors. You can use SQL functions to query the data, and you can have semantic key searches using Iris, InterSystems IRIS. You can see here the support for vector search. So when you go to the patient summary, here we used the vector search to store the vectorized data from the embeddings of the clinical data, and you can save here and use in your queries. And embedded Python is very useful to call AI functions using Python, as you can see here. Here I created the vectorized patients, and you have embedded Python here. You declare, you set the class method is language Python, and you write the Python code here inside Iris, and we get the FHIR server, get the response, use vector search to save the data. We used Ollama FHIR to embed data from the FHIR server and insert into the patient summary. So I used Ollama to convert the patient's data into vectors, into embeddings, and save inside patient summary to use in my responses, in future responses provided by Ollama. Okay. So embedded Python inside InterSystems IRIS is a powerful tool to bring the LangChain and other libraries using AI to meet your requirements. As you can see here, we have a smart patient summary generator, and now you can see that it's possible to the user using stringlet select a patient ID, stringlets using Python fetch the FHIR bundle data about a patient observation, and other resources about a patient, set as a bundle, and return JSON bundle to stringlet. Stringlet now with the all patient data, the patient demographic data, any observations, any conditions, and send this to Ollama running Llama 3 LLM model. And Ollama processes the data, generates a clinical summary of this FHIR data, and display to the user using stringlet. Okay. So you can see here FHIR is the core because it is the FHIR server of the solution, and using vector search allowed to Ollama enrich the response to the user. Okay. And in the second scenario, you have a natural language to FHIR query explorer. So the user asks any natural language question, like list male patients with diabetes, and the stringlet asks to Ollama to translate this natural language question to a valid FHIR query, and Ollama transforms this in a FHIR call, REST FHIR call to the IRIS FHIR server that responds this API call with a response with all FHIR resources, and the stringlet with this data summarizes the results using Ollama and vector search for the InterSystems IRIS, return a textual summary, and return the textual summary and the JSON of the call in the InterSystems IRIS for user. And in the last scenario, we have a user with a patient ID to string leads, fetch the observation resources, and filter the observations, and filter their observations with numbers and datas in data. Only observations that have numerical values, and send this to Panda table. And with this Panda table, I asked to Ollama, what is the charts that you can generate for me? And the Ollama generates these charts using Python script. And this Python script is executed in string leads, but can be executed in embedded Python also. And with the string lead line charts, return to the user see all observations of a patient using charts. You can see the results here. Okay, patient ID generate charts, and we have all charts generated by AI. Here. Okay. So we have with this architecture a powerful set of tools to create fantastic scenarios to support hospitals, doctors, patients, to get insights about the FHIR data. And IRIS is the core, because AI without data is not a powerful tool. Ollama, Llama 3 can handle clinical data because it has access to the FHIR Server from InterSystems IRIS, and use embedded Python, vector search to deliver these short responses. Okay, so download my app and test and see the results of this fantastic architecture. Thanks.